Hello, hi everyone. My name is Sameka. Today I'm gonna be talking about solar panels. Obviously, I know people might say that it's different from what I usually talk about. I always concentrate on my main topics were mainly on corrosion, materials and corrosion. But today I want to talk about solar panels and battery. The reason being is that I've recently installed one in my house, and the reason why I'm giving this video is because I want to try and, is it quench? Maybe quench? No, I'll say make people believe that solar panel do work in the UK because there is this belief that solar panels is a waste of money in the UK because we hardly get any sunlight. But this video is just to try and make people understand that actually solar panels do work in the UK and they could, and basically they will save you a lot of money, especially with the high cost of electricity. So we'll talk about that today. Um, so the main title of this presentation is basically is solar and battery worth it? Are they really worth it? Yes, the honest truth is that yes, they are worth it. I've, as I said, I recently got it installed in my house, and I've managed to get 1 month of data, and to prove that it actually works, and it has saved me quite a few amount of money, especially for February, which we all know is one of the worst month of sunlight. So, but I still managed to make some good savings with solar panels. So I'll discuss that. We'll talk about that as we go on the page. So my system. So basically, um, for my solars, for the system which I have, I've got. So for my solar panels and battery system, which I have got installed in my house, is got 12 panels, which are rated for 435 watts panels. And they are the Jinko solar panel. I've got 7 Pygo optimizers, 6 kilowatts hour grow watt inverter, 5 kilowatt battery storage, and a solar eye booster. This is what I've got installed in my house. I will go through every one of them to explain the reason why and what they do. So we've got the 12. I've got 12 Jinko Tiger Neuro N-type solar panels installed. Why did I go for this type of solar panel? Number one, they are monocrystalline. Monocrystalline means that they pick up electricity or say sunlight at very low light. So even if it's very useful for places like this in the UK where there is not a lot of sunlight. With monocrystalline solar panels, they are very good because they can pick up really low light. Polycrystalline ones are not very good for, I would say, you doesn't mean you can't use it, but they don't pick up low light. So I'll give you an example for my solar panel. Even though there's not a lot of sun, as long as there's very little sun, it can pick up something close to about, say, 10 watts of electricity. As low as that just tells you how low it is. Well, polycrystalline, I think, will only pick up starts producing electricity when it hits about 200 watts or maybe more. I'm not 100% sure, but that's why That's why I went for monocrystalline solar panels. Um, so as explained, they send they do pick up electricity at low sunlight. It comes with a 25 years warranty. And it's also got a 0.4% annual degradation over 30 years. So, the older they become, the more they degrade. So, but 0.4 is a very small number over 30 years. So that's why I went for this type of solar panel. And the last thing is the looks. Obviously, as the looks also. It's also appealing for me because obviously you don't want ugly um, solar panels hanging on your roof and everybody looking at it. Not You're looking at it every day. It's not really nice. So I felt the black does match the roof a lot better and it makes it look quite nice. So yeah, they're nice to look at. So these is the type of solar panel I went for. Um, so how did I spread the solar panels? So basically, looking at this, you will see that the dark side. This is my house is a bit like an L shape. So you've got the front side, which is a dark bit there. It's the front of the house. I didn't put any solar panels there because, as you can see, there's quite a lot of shading, so we don't really get a lot of sunlight throughout the day on that side. So it won't make sense to put any solar panel there. So I put it on this side where I put 5 on this side. Should have been able to put more, but because I have a window there, which is like a dome window there, and that's obstructing putting anything extra. So I managed to squeeze in about 5 solar panels there. On the other side, we have 7 solar panels. That's okay. Well, we were able to manage to put 7 there. We can actually push it to 8, but that's as far it can go on that side of the roof. And then here, we could put in some solar panels in this side, but obviously there's 2 windows there, so skylight windows, so we couldn't put too many panels. And secondly, the issue with the sun as well. So even though we can squeeze in maybe 2 here, when the sun rises, it's not really going to have much effect because as the sun rises and then moves around, it wouldn't actually make sense to get quite a lot of electricity from here. So the plan was we put it at this 5 here so that when the sun rises, you produce electricity from 5 of these solar panels, and as the sun begins to move, and when it gets to this point here, where in the middle, like between 10 and 1 o'clock, when the sun is at its fullest, the 7 panels start producing electricity the same with the 5 panels, and the 5 panels would produce electricity all the way to nearly sunset, and including the 7 panels as well would also produce electricity. So so it was a good idea putting 5 of the panels up there and then 7 on this side, so that as the sun rises and then sets, you would be producing as much electricity as possible. So that's how I have actually basically requested for my solar panels to be spread out on the roof. So just to make sure the sun from my side, in terms of sunrise, the sun rises from the east, and that's where the 5 of the solar panels are facing, and then it sets southwest, where the 7 panels is facing. So the next thing I have on which is installed, and these are installed just underneath the solar panel, is the Tigo optimizer. I have 7 of them, 3 on where I installed the 5 solar panels, and 4 where I installed the seven solar panels. Uh, so what does this do? Basically, the optimizer is its job is for shading effect. So basically, if I'll give you an example. If there is if you've got, because mostly the solar panels are connected in parallel. So if there is a shading on one of the solar panels, that that means that the solar panels power will be affected by maybe half. That's if half of the solar panels is shaded. And because of one solar panel being shaded, and then because they're on in parallel, it means that all the other seven, all the other solar panels would be generating half its electricity, even though they're not shaded. So what this optimizer does is that rather than the effect of that shading on one solar panel affecting the rest of the solar panel, it would redirect the electricity so that the other solar panels are not affected by the shading. So this is why it's I got this installed, because there's buildings close to my house that could, as the sun moves around, it could be causing shading in most of the solar panels. So I have this installed to reduce the effect of the shading. Um, the next one is I is the 6 kilowatt grow watt inverter. I was supposed to get a 5 kilowatt inverter, but unfortunately they didn't have a 5 kilowatt inverter, so they gave me a 6 kilowatt inverter for free. For free. Well, I won't say it's free anyway, but but a much bigger inverter that they gave to me. So what does this do? Basically, it converts DC current to AC current. So the electricity that comes from the solar panels are DC current. So what the inverter does is converts it to AC current so that you can be able to use it at home. Remember, you can't use DC. Remember, DC currents cannot be used in your house. It will blow out the whole system in your house. So that's why it has to be changed, converted to AC current before you can use it. So basically, the hybrid inverter, which is what it's called, is more or less connects the solar panels, the battery, to our consumer units, and then to the grid. So they're more like the brain box of the system, if you want to call it that way. So basically, what they do is that they prioritize the solar panel first to feed the main house, and if there is enough solar, it would charge the battery, and then also send the rest of the electricity to the house. And then when there is no solar panel, or there's less solar panel, less electricity being produced by the solar, it would take some of the energy from the you will use it would use some of the energy from the solar panels, and then request the battery to discharge its energy to help to thanks to the house. And then when there's no sunlight at all, and then it would then change its priority to the battery to discharge its energy to the house. And then once the battery runs out, it will then um, change its priority for the grid now to now supply the electricity to the house. So basically, in summary, it looks at the solar panel first, and then the battery, and then the grid. So so the next thing is the 5 kilowatt battery rich storage. So the function obviously of the battery is basically to store energy. So all the energy, the solar panel can produce a lot of energy, electricity. Most of that wouldn't be consumed, so they have to go somewhere. So rather than it being going back to the grid, you can store those energy in the battery and use it later on in the night where when there is no more sunlight. So basically, the function of the battery is just to store the energy. from the solar. So the other thing which I have installed was a solar eye booster. So basically, this what this does is more or less it just to heat is to heat up the hot water tank with solar. So as I mentioned before, when there's quite a lot of electricity being produced by the solar, uh, it will charge the battery, and when the battery is fully charged, those excess electricity goes to the grid. Now, what the eye booster does is that as they're going to the grid, the eye booster would transfer that electricity to the hot water tank, because my house uses a hot water tank to supply hot water to the taps and also for to the taps. So it was redirect the electricity to heat up the hot water tank. So sorry, just to go back again, my hot water tank uh, is is heated up by either gas or electricity. So because there is enough solar energy that the iBooster uses now heats up the water using electricity produced by the solar panels to heat up the water, so that I will avoid me using or avoid using gas to heat up the whole water. So it's free electricity. So why not use it to heat up the hot water? And that's another way of trying to store the excess energy that the solar panel produces as well, by storing it in the hot water to be used in the main house. So that's what the iBooster does. So how does the system work? So as I mentioned to you before, so the solar panel, when there's energy from the solar panel, electricity from the solar panel goes to the inverter, it charges up the battery, and then um, and at the same time too uh, sends electricity to the main house. And um, if there is no solar, the battery kicks in and then starts to supply electricity to the main house until when the battery runs out, and then the inverter will then call for electricity from the grid. That is what it does throughout the day. So afternoon, morning, afternoon, and then night. So that's what the inverter does. It just acts like the brain of the whole system. So I'm going to talk about a bit about the data, which for February. So I'll look at the um, total amount of solar which was produced for February, how much that was exported, and then obviously how much that I got from the grid itself. So solar and battery production for the month of February was about 348 kilowatts hour. And then out of that 348, I only consume about 257 kilowatts. 91 kilowatts was exported to the grid. By the way, even though I did mention exported, most of those energy was actually used to heat up the hot water, as I mentioned before. So it might be less than, I think it's going to definitely be less than 91 kilowatt being exported. And then grid import was 443.7 kilowatts. So in terms of savings, how much it cost me. So for the cost without solar, with all that figures which I've showed you, it would be 600, so 660.9 would have been my total consumption of the for the for the month without solar. Multiply that by how much it costs per kilowatt. It's about 0.28, and that gives me about 185 pounds. That is how much I would have paid if I didn't have solar panels. And and now when we look at how much it costs with solar without solar panels, it's about it's about 257 times um, 0.28, and that gives me about 113. So basically, subtracting those two, it gives me a savings of about £72 on electricity alone. And that is, even though that's not much, but that is a huge saving for a month that there is not even a lot of sunlight. So there is still considerable amount of savings to be held in February, even though there is no enough sunlight. And then for gas, this one was quite interesting. So what I've done with this one, I've compared the data to last year February to this year February. So last year February, obviously I didn't have the iBooster, so solar iBooster. I'm comparing the data to this year February. And another thing too, the cost last year was considerably high. So for gas, so what I've done is basically just for fairness, just use the same the same price for this year, and just to see how much I would have saved. So with without iBooster, I would have been paying £264.8, which is what I paid last year, February, for the month. And then come this year with iBooster, I was able to, it brought it down to £171.9. Subtracting the two, that's there being 92.9 savings. So it just shows to you what difference the iBooster does make by just heating up the hot water and not using the gas to heat up the hot water. So there's quite a few amount of savings there. So the next thing I would like to use this moment to also, for those who are interested, because as you can see, so for me, the solar does work. And trust me, I did have that same concept that solar would never work in the UK. But after hearing a lot of testimony, and I'm giving my own testimony as well, because it actually works, and yeah, it's worth installing solar and battery here in the UK. So on the screen, I've actually shown the company and the sales service company that have actually made it possible for my solar system to be working today. So Samco Solar, they do the sales, they do the sales service. So they come do a survey of your property, and then they can then give you an idea of the best solution for your house. And then Unclouded Solar, they work with Samco Solar, so they would be mainly the installer. So they would install the battery, the inverters, and then do all the wiring, and also install the solar panels on your roof. So they're very good at this, at doing their job. And the good thing I love about them is that even though they've installed a system, they always keep they're always available for any questions that you would have, or if there's any issues as well, they will always be available to come and see you, or sort the problems out. So it's more or less that they're always there for you. So it's not like most companies that just come and just install and just disappear, and whatever happens is your problem. No, they are very good at responding to any issues that you have. So if you have any plans of installing solar panel, I will put the description I'll put the website on my description page, so you can have a look and give them a call. Thank you for listening to my solar panel presentation, and I hope you enjoyed it. And I hope you would not have that same concept that solar panel don't work in the UK.